in the last class. Please find in your WhatsApp group. Please find this question number 4. A spaceship is traveling with a velocity of 0.7 c from the space station. So here, this is question number 4. Question 4, and this was asked in GATE 2018. GATE 2018, this question was asked. Now there is a spaceship here. You can say, this is a spaceship is traveling with a speed of with a velocity of 0.7 c away from the space station. So I'm saying this is a space station. And from here, a spaceship is moving. This is a spaceship that is moving. Okay, and it is moving with 0.7 c away from the station. This is 0.7 c. So what is this velocity? This is the velocity of the spaceship. Okay, I assume it as A and I assume it as S. So velocity of A with respect to space station, A with respect to S, that is plus 0.7 c. So this is the first statement, beta. The spaceship ejects a probe with a velocity of 0.59 c opposite to its own velocity. So there is a spaceship, this ejects probe. There is a probe here, it is ejected a probe. This is probe. And it is moving in the opposite direction with a velocity of 0.59 c. Okay? It is moving in the opposite direction with 0.59 c. Okay? Now what will be this 0.59 c? Can anyone tell me? What is this velocity given? This is ejecting a probe which is moving in the opposite direction with 0.59 c. So what will be this velocity of the probe?
PA.
With respect, correct, beta, very good. Velocity of the probe with respect to spaceship A. And this will be because it is moving in negative direction. So this will be minus 0.59 c. So if you are using this formula, you don't have to think anything. You just have to understand how to apply the formula only. Sorry. A person in the spaceship station would see the probe moving at a speed of x into c. So there is a person here. Okay, you want to find out the velocity of this probe with respect to space station. What is your objective? Velocity of the probe with respect to space station. So P is there, probe is there, space station is there, spaceship is missing. So what it will be? This will be velocity of probe with respect to A minus velocity of the space station with respect to A divided by 1 minus VPA VSA divided by C square. So what is VPA? That is minus 0.59 C. 0.59 C. VSA will be opposite to this. Try to understand. This will be minus 0.7 C. So this will be this will be minus 0.7 C here divided by, this will be 1 minus 0.59 c, 0.59 c minus 0.7 c divided by c square. Find out this value, beta. This will be VPS. Please find out this one. So how much you are going to get? This will be 0.187 c. This will be plus. So plus will be greater, minus will be lesser. So your answer is 0.187 c. You calculate it. I'm just writing the answer here. So you will get this answer. So this is question number 4 that was asked in the exam. Next question, beta. Question number 5. Now go to question number 5. Next is question number 5. Go through this. A beam of light is propagating. So this question was asked in JAS 23. JAS 23. A beam of light is propagating through a block of glass with refractive index n. Okay, the block is moving with a constant velocity in the direction opposite to that of the beam. Okay, opposite to that of the beam. So basically, a beam of light, what they are saying, a beam of light is propagating through a block of glass with refractive index n. The block is moving with a constant velocity v in the direction opposite to the beam. Okay. So this is the situation. Try to understand. This is Earth or laboratory frame. This is Earth, or you can say lab frame, whatever you want to say it. There is a block, you can say, of glass. Okay, and in this block, a light beam, it is moving like this. This is light beam. I am representing it by L, and this is a block, and I am saying this block is B. Okay, Earth is E, and here light, this is light, I am representing it by L. So block in which direction? Block is moving in the opposite direction of the propagation of light beam. So this will be, ठीक है ना? In this direction it is moving with a speed v. So first you are going to tell me velocity of this. What is this v? This is the velocity of the block with respect to Earth. So velocity of the block with respect to Earth is this. ठीक है? This will be velocity of the block with respect to Earth, and that will be minus v. Minus v. Second, this light is moving in the block. So what will be the velocity of the light with respect to block? Velocity of the light with respect to block. In air, ठीक है ना? Speed of light will be c. Here refractive index is n. So here this will be c by n. In the block, velocity of the light will be c by n. So velocity of the light in the block will be c by n. With respect to block, velocity of light will be c by n. Now what you want to find out? Speed of the light beam in block as measured by an observer in the laboratory frame. So you want to find out velocity of the light as observed by this person. What will be the velocity of the light as observed by this person? So you want to find out velocity of the light with respect to Earth. So here light is there, Earth is there, block is missing. So velocity of the light with respect to block minus velocity of the Earth with respect to block divided by 1 minus velocity of the light with respect to block, velocity of the Earth with respect to block divided by c square. So whatever is given, substitute here. Velocity of light with respect to block, so this will be c by n minus v, this is vbe, so what will be veb? That will be plus v. So here this is going to be plus v sorry, minus this will be c by n into
सर
v. Yes beta, please.
सर सी बाई एन प्लस बी होगा ना?
c by
सी
n,
बाई
हाँ.
प्लस बी जो वैल्यू रखे हैं आप.
No, actually what is this? This is velocity of the Earth with respect to beam. And what is this? This is the velocity of the beam with respect to Earth.
यस
ठीक है?
सर.
So what will be the velocity of the Earth with respect to beam? That will be minus velocity of beam with respect to Earth. ठीक है? ये कितना दिया है? माइनस v. So this will be minus V. This will be V here. ठीक है? So velocity of
Yes,
Earth
sir.
with respect to beam is V. So C by N
Yes, sir.
minus V divided by 1 minus C by N V, and this will be C square. So it is going to be C by N minus V divided by 1 minus V by NC. This type of answer you are going to get. Now you can check which one is the correct one. So this will be option D. ठीक है ना? Option D is looking like this. Take the LCM. So this will be C minus NV divided by, ठीक है, C by NV. So here you are going to take the LCM. So this will be NC minus V. N will cancel out and C will be here. ठीक है ना? It should be like
Dividing
this.
denominator by C would give the option D.
Okay. Yes. So agar beta, yes, you are correct. So V by C is there. You are getting V by C here in the option. So it's better कि आप केवल N का LCM लो. So then it will be correct. Remove this. Just take this LCM for N only. So N will cancel out. And this will be N minus V by C beta. ठीक है? So you can write V by C here divided by N. So this will be N minus V by C and N will be cancelled out. This will be the answer, option D. So option D is the correct answer. Option D will be the correct answer. Next question, beta. Is this clear to everyone?
Yes,
You will find out this type of question they have asked many times, 3 or 4 times. Next question, beta. Question number 6. Gate 24. Question number 6. Gate 24. Now, this is an inertial observer sees two spacecrafts S and T flying away from each other. So there are two spacecrafts S and T, and they are flying away from each other along x-axis with individual speeds 0.5 c. So you can say one is moving in this direction. ठीक है? It is moving like this. 0.5 c. You can say this is S. There is another one that is moving in this direction. This will be T. It is also moving with 0.5 c. From where you are observing these velocities? From the Earth. From the Earth. ठीक है? So velocity of S with respect to Earth, that is minus 0.5 c. Velocity of T with respect to Earth, that will be plus 0.5 c. This is given to us. ठीक है? The velocity of T with respect to S. Velocity of T with respect to S. So that's very simple question. T with respect to S. Find out velocity of T with respect to Earth minus velocity of S with respect to Earth divided by 1 minus VTE VSC. Just substitute these values and find out the answer. ठीक है? You just have to substitute these values. This comes out to be 4 by 5 C. ठीक है बेटा? So this comes out to be 4 by 5 C. Correct beta? This will be. So this was another question. Next question. Question number 7. Gate 22. Question number 7. Gate 22.
Sir,
Yes, beta, please.
the answer would be 4 by 3, I think.
No, it will be, I think, 4 by 5. What you are going to get? C upon 1.25. You will get C upon 1.25. ठीक है? If I substitute here, this will be 0.5 C. ठीक है? and this will,
यस सॉरी सर मैंने वो प्लस माइनस में गलती किया.
okay beta. So this was question number 6. Now go to question number 7. Gate 22. Gate 22. Two identical particles of rest mass m naught. Two identical particles of rest mass m naught approach each other with equal and opposite velocities. Okay. So the total energy of one particle as measured in the rest frame of the other is alpha m naught c square. So you have to find out energy of one particle as measured in the rest frame of the other. So here first, this is one of the particle. I'm calling it as A. There is another particle, that is B. So it is like this. This is B. And they are approaching towards each other. What is the speed? They are having 0.5 c. So this is 0.5 c. This will be 0.5 c. So velocity of A with respect to Earth, 0.5 c. Velocity of B with respect to Earth, minus 0.5 c. This is given to us. Their rest masses are m naught. Its rest mass is m naught. Its rest mass is m naught. What you have to find out? You have to find out the total energy of one of the particle as measured in the rest frame of the other. Okay? So I say I will find out. I can find out what velocity of B with respect to A. Okay? I can consider this. First, what is my interest? I want to find out energy of B with respect to A. So I'm considering energy of particle B in the rest frame. It means I'm calculating in the rest frame of A. I want to calculate the total energy of B in the rest frame of A. I want to do this. Okay? So what I'm trying to do, I'm making it as this is A. I'm making it a rest frame. Okay? I'm making A as the rest frame, a frame attached with A, and I will find out this B. What will be the velocity of B here in this frame? So you will find out velocity of B with respect to A. So first find out velocity of B with respect to A. So this will be VB with respect to Earth minus VAE with respect to Earth A 1 minus VBE VAE upon C square. So this will be minus 0.5 C. This will be minus 0.5 C divided by 1 minus. Okay. So 1 is plus, 1 is minus. So this will be plus 0.5 into 0.5, 0.25. And C square will cancel out. So this will be minus C upon 1.25. Okay. So this will be how much? Okay. This will be 0.25. So this will be minus 4c upon 5. Okay. So this will be minus point, and this will be minus 4c upon 5. So what you are saying this B is moving towards A with 4c upon 5. So this person is observing who is in the frame of A. Now, what is total energy? Formula of total energy if velocity is given. If velocity is given, what is the formula of total energy? In relativistic mechanics, however, I am not there. ठीक है, and I have not reached at this point, but I am telling you in STR, in Special Theory of Relativity, ठीक है, total energy of a particle, it is given by one of the formula is you know about it, P square C square plus m naught square c to the power 4. This will be the total energy if momentum is given. If P is given to you, you will use this formula to calculate total energy. Another formula is if kinetic energy is given, then kinetic energy plus rest mass energy. This will be the formula if kinetic energy is given. If they are providing you velocity, then you will use this E equal to mc square, and this is relativistic mass. So your formula will be m naught, this will be m naught c square divided by square root of 1 minus v square upon c square. This formula you are going to use. So what is this? This equation says that if in a frame, this is a frame, in this frame, an object is moving with a velocity v with rest mass m naught, then according to this person, what will be the energy of this particle that is given by this? Okay, so E will be m naught c square. So in the frame of this person, if this object is moving with a velocity v, then its total energy will be given by this. I will come to this later, but because I have to use the formula, that's why I'm telling you. So this will be the total energy, beta. Now I'm going to use this formula. Now look here, according to this person, this object is moving with 4c by v. So what will be E here? Okay, according to this, E will be m naught rest mass energy c square divided by square root of, this is 1 minus velocity of b with respect to a square upon c square. Okay, so because he is measuring the energy, so according to this person, what is the velocity of b? You have to find out first. So you have already find out minus 4c by 5. So it will be m naught c square divided by 1 minus 1 by c square vba square. So this will be square, so minus will be gone. So this will be 16c square divided by 25. Okay, this will be. So here c square is going to cancel out. This will be 25 minus 16, 9. So this will be 3 by 5 here. So this will be 5 by 3 m naught c square. This will be the energy of B as observed by A. Okay, na? This is the energy of B as observed by A. This should be the answer. 5 by 3. So what they have given? They have given energy alpha m naught c square. So they are equating it as alpha m naught c square.
Then
So
alpha is equal to 5 by
alpha is
3.
5 by 3. Correct, beta. So alpha is 5 by 3. This will be the answer. Okay, because this is a, you have to fill a blank here. So find out in decimal up to 2 decimal places. So this will be 1.67. How much it will be? This will be 1.67. This will be. Is this question clear to everyone? This was question number 7. Now go to the
Yes, sir.
good beta. Now go to next question. Question number 8. So STR is a topic. Most of the students they find it difficult, but actually, okay, you please attend all the classes and you will find out this is a topic from which you can always solve the question. This is actually very systematic. Okay, just use the formula, but you should understand how you are applying the formula and how you are understanding the statement that is given in the question. So if you start understanding the statement that is given in the question, then it is very, very easy to solve questions of STR. So question number 7 was this. Now go to
Yes,
question
sir.
number 8, beta. Please solve. Everyone, please try to solve this question. This is a simple one and find the answer. Everyone, please solve. Question 8, please read this question and solve. This question was asked in JES 23. JES 2023. Please solve this question. C by 2. This is a very good question. बताइए बेटा.
2c by 3.
2c by 3 बेटा. ठीक है. So
Yes, sir.
what they are saying, velocity of the rocket क्या दिया हुआ है? Just first this is not given. So a rocket is moving. ठीक है. Try to understand. A rocket is moving like this. ये कोई rocket है बेटा. It is moving. This is a rocket. And in starting, the rocket is moving in free space with c by 2. ठीक है. And initially it is moving with c by 2. Try to understand with respect to Earth. With respect to Earth. Now, a part of it which is detached here, which was a fuel was attached here. So a fuel is detached. This is a fuel tank that is detached with it. So it will continue to move because at the time of detachment, try to understand what is the speed of this. That is c by 2. So it will continue to move. This one is going to move with c by 2. So velocity of the fuel tank with respect to Earth, that will be c by 2. At the time of detachment, it will remain. This is tank. ठीक है. So fuel tank, you can say this is fuel tank. F लिख सकते हो, you can write. So this is c by 2. After a fuel tank is gently detached, the rocket is found to moving with a speed of c by 4 with respect to the detached fuel tank. So velocity of the rocket with respect to fuel tank, that is how much? C by 4. So these two quantities are given. C by 4. Now they are saying us what is the final speed of the rocket in the original frame of reference. My original frame of reference was Earth. Try to understand before this detachment, this fuel tank as well as this rocket, they were moving with c by 2. This was detached. इसके पास it doesn't have its own engine. Fuel के पास engine नहीं है. So for the time, ठीक है ना, it will continue to move with c by 2. So at the time of detachment, it will be VFV equal to c by 2. ठीक है, c by 2. Other forces are not acting on it. Now, basically now this rocket is moving with respect to fuel by c by 4 speed. So you have to find out velocity of the rocket with respect to Earth. This was a good question. ठीक है. In terms of thinking, you should be aware. जैसे आप car, if you are suppose you are moving with a truck or something, and truck is moving with some. So try to understand. This is a similar type of question you have done in your class 11. और ठीक है, so if you are having a truck, ठीक है, this is that type of problem. This truck is moving with a velocity v, ठीक है. If a person who is standing here, ठीक है ना, he gently dropped something here. Try to understand, he gently dropped some object. So at the time of drop, ठीक है, its velocity, it will be v, and then it is going to follow the projectile motion. So try to understand at the time of just a small simple drop, ठीक है ना, its velocity will be the same as that was of the truck. Similar situation is here when rocket is moving. So due to inertia, this fuel tank, it will continue to move with the same speed, c by 2. So that's why this is c by 2. So velocity of the rocket with respect to earth will be, rocket is there, earth is there, tank is missing. So VRT minus VET divided by 1 minus VRT VET divided by C square. C square, ठीक है, C square. So substitute all values. RT, I'm writing F, sorry. Tank की जगह I'm writing it as F. So please make it correct. F. So VRF is how much? C by 4 minus F is C by 2. So EF will be minus C by 2 minus C by 2 divided by 1 minus C by 4. This will be minus C by 2 divided by C square. Okay, this will be the velocity of the rocket with respect to Earth or with respect to its initial frame of reference. ठीक है, कैलकुलेट करो जरा इसे बेटा, कितना होगा?
3c by 4 by 9 by 8.
I have done it correctly, na? This is
3
एक मिनट बेटा, what I have done, R and E, R and F, this is E and F. So I think it should be correct. So this will be C by 4 plus C by 2 divided by 1 plus, this will be 1 by 8. So this will be 2. So this will be 3 here.
That's 6 by 9 into C.
So this will be 3 here, and this will be 8 plus 1, 9. This will be 4 to the 8. So this
2
will be
by
3
3C.
by, just यार क्या हो रहा है?
So final 2 by 3C.
हाँ. So this will be 2C by 4. So this will be 3C by 4 here, and this will be 9 by 8. So 4 to the
Yes,
8,
sir.
3 the 9. So this will be 2 by 3C. ठीक है
Yes,
ना?
sir.
This should be. Now, next question, beta. This is also a very good question. Next question. JEST 2014. JEST 2014. Question number 9, beta. JEST 2014. This is a good question, beta. It can be repeated. One more time they have asked a question very similar to this. A monochromatic wave propagates in a direction making an angle 60 degree with the x-axis in the reference frame of the source. So what they are saying, this is Earth. ठीक है? Here there is some light source. There is some light source. ठीक है? Some source is here. ठीक है ना? This is a source. And in this frame, in the frame of source, ठीक है? This angle is 60 degree. So what will be the speed of light here? Speed of light will be c. Okay? Speed of light will be c. So try to understand velocity of the light. Okay na? Velocity of the light. This is light signal. Okay? With respect to the source. Okay? Velocity of the light with respect to the source is c, but c, it is moving in this direction. What will be the component of this velocity of the light with respect to source? If you write its x component, this will be c cos 60 degree. This will be c cos 60 degree with the x-axis in the reference frame of the source. The source moves with a speed of 4c/5 towards the observer. So observer is here, and speed of this source is 4c/5. 4c/5. So what is this? This is velocity of the source with respect to, you can say, the observer or the earth. Okay, try to understand where is observer is standing. Observer is standing on the earth. Okay, earth and observer are same. Okay, so frame of the observer or frame of the earth is same. So I'm writing observer. Okay, so velocity of the source with respect to observer or the earth. Okay, now observe, this is how much? It is in plus direction, so I'm writing 4c/5. And you are aware this is also in x direction. So this velocity is in x direction. Okay, I have find out its component in the x direction. Now find the direction of the wave as seen by the observer. Now you want to find out what is the angle at which according to the observer light is propagating. I don't worry. ठीक है ना? So what I want to find out? First I want to find out velocity of the light with respect to observer and its x component. This is also in x. So every velocity here I have chosen in the x direction. Okay? I find out velocity of the light with respect to source x component of this. Velocity of the source is already in x direction. That is okay. I want to find out velocity of this. Velocity of the light according to this observer. So velocity of light with respect to observer, and I'm finding its x component. ठीक है, आई एम फाइंडिंग इट्स एक्स कॉम्पोनेंट. ठीक है, ये बताओ कितना होगा. It will be, try to understand why I want to find out. I'm going to tell you. If I know according to observer, ठीक है, try to understand. Suppose according to observer, suppose light is moving like this. According to, this is source, this is according to source, and according to observer light is, I don't know what will be the angle. ठीक है, so I'm saying this angle is suppose theta. ठीक है, this will also be c. Try to understand velocity or speed of the light in air will remain same, c, in all the frame. If when light was traveling here according to the source, its speed was c. When light according to observer light is propagating like this at an angle theta with the horizontal, but speed remains c. So what will be the x component of this? Velocity of light with respect to observer and x component, this will be c cos theta. So I will equate it as c cos theta. So from here I can find out c cos theta if I know this quantity. Try to understand, if I know this, then this x component of the light with respect to observer, this will be c cos theta. C cos theta. So what is this? This is velocity of the light. Light is there, observer is there. ठीक है, source is missing. Velocity of the light with respect to source, x component. Velocity of the observer with respect to source, x component, divided by 1 minus this velocity of observer with respect to source x divided by c square. This will be, so c cos theta will be how much? C cos theta, this will be equal to ls. This is c cos 60. C cos 60, how much c cos 60? C by 2 minus sign. Velocity of the observer with respect to source, this is VSO. So what will be VOS? that will be minus 4c by 5. So this will be minus 4c upon 5 divided by 1 minus c by 2 minus 4c upon 5 divided by c square. So c cos theta, this will be, here c will be common, 1 by 2 minus plus 4 by 5 divided by, this will be 1 minus 2 2 ja 4, ठीक है, here. So this will be minus minus plus plus, this will be 2 by 5. 2 by 5. ठीक है बेटा, तो ये देखो c से c कैंसिल हुआ, cos theta that will be 10 here, ठीक है, 5 here plus 8 divided by, this will be 7 by 5, ठीक है, so 5 2 ja 10 and this will be 13 by 14, ठीक है. So what will be theta here? I'm writing here theta will be cos inverse 13 by 14. This would be the answer, beta. Cos theta should be 13 by 14. This is the answer. Correct answer is this. Is this clear to everyone?
Yes, sir.
Good, beta.
Yes, sir.
Yes, beta. Good. Question number 10. Now go to question number 10. This question was asked in June 13. Kariye solve and please tell me what is the answer. Please, everyone is going to solve question number 10. This was asked in NET examination, June 2013. CSIR 2013. Question 10. Everyone can solve this question. Now it is very easy for you. And tell me the answer. This is just the language. Otherwise, simple formula application is there.
Sir,
Yes, beta.
sir, velocity of CB minus velocity of CA upon 1 minus CB into CA by C square.
Just tell me the final answer, beta.
Yes, sir. Explain it.
Option B, 4C by 7.
Correct, beta. Very good. 4c by 7. So option B is correct. I hope everyone is able to solve this.
Yes, sir. 4C by
Good.
7.
Yes, sir.
Good, beta.
Yes,
Now
sir.
go to next one. Question number 11. Solve it. This question was there in June 18. Question number 11, June 18. Solve it, beta. In the next class, I will discuss all questions related to Laurent transformation equation. There are many questions which are asked in different exams related to Laurent transformation equation. Okay? So I will share questions with you and we will discuss those questions. And then we will move forward after discussing those questions. Then I will move to time dilation, length contraction, and principle of simultaneity.
Sir, 2v by 1 plus v square upon c square.
Yes, beta. This will be 2v upon 1 plus v square upon c square. This will be the answer. I have solved this question many times in between questions. So, is it clear to everyone?
Yes,
Yes,
sir.
sir.
Good.
यही है.
यही आएगा नेक्स्ट. अब आप करिए बेटा ये क्वेश्चन नंबर 13 करिए. ये तो हमने अभी किया था. क्वेश्चन नंबर 14. सेम क्वेश्चन इज देयर. क्वेश्चन नंबर ये करिए 13. दिस इज ऑल्सो लाइक दैट बट प्लीज सॉल्व दिस. क्वेश्चन नंबर 13. सॉल्व इट. ठीक है, ये भी एग्जाम का क्वेश्चन है बट आई डोंट नो इन विच ईयर. बोलिए बेटा. So, I am making the diagram, then you can easily solve. So, this is Earth.
यस सर, इसमें फ्रेम ऑफ रेफरेंस समझ नहीं आ रहा है.
हाँ बेटा,
क्या
वही मैं
लेना
बता
है?
रहा हूँ. वही मैं बताता हूँ. ठीक है.
ओके.
There is a tube here. ठीक है. This type of tube is there. So, tube and Earth are same because tube is fixed with the Earth. So, this is a tube like this in which fluid is flowing. So, this is a tube. So, you can choose in place of Earth, you can choose the reference frame as tube, rest frame. So, I will write it as tube. In this tube, fluid is flowing. So, fluid is flowing here. So, it is flowing in this direction. What is the velocity of the fluid? V with respect to stationary narrow tube. So, this is V. So, what is this V? V is velocity of the fluid with respect to tube. That is V. ठीक है. Now, if light pulse enters into the fluid in the direction of the flow, so it is moving like this. ठीक है ना. This is light pulse.
Sir,
And it will just C by N. So velocity of the light with respect to fluid, that will be C by N. Yes, beta, please. What you are saying?
sir, options C.
Very correct, beta. Option C. So this is given. Now what you want to find out? What is the speed of light pulse measured by the observer who is stationary with respect to tube? So a person who is standing with this tube, ठीक है ना, उसके रेस्पेक्ट में बताना है. सो यू वांट टू फाइंड आउट वेलोसिटी ऑफ द लाइट with respect to tube. ठीक है, now find out velocity of the light with respect to fluid minus velocity of tube with respect to fluid divided by 1 minus VLF VTF divided by C square. So this will be LF, this is C by N, minus this is TF, so this will be minus V divided by 1 minus C by N minus V divided by C square. Now you can check which one is the correct option. So option C is the correct option. Beta. ठीक है ना, option C. So from here this one C will cancel out. If you look at the options from numerator, they have taken this, you can check. So here they have taken this C by N common. If you look into the options, so if you take this C by N common from the numerator, here it will be 1, ये plus होगा, and this will be NV upon C. It will become divided by, here this will be 1 plus V by NC. So option C is the correct option. So this was also a good question. Next, beta. Just next question करिए बेटा. This question was the question number 14. करिए जरा. Question number 14. Now solve question number 14.
सर माइनस सी.
That will be minus C, beta. ठीक है? That will be minus C. Is it okay with everyone?
Yes, sir.
So this question number 14, answer is option B. Option
Yes,
B is the correct option. Now go for question number 15. ये भी same question है बेटा. I think this is repeated. Now go for question number 16. Now solve question number 16. This was asked in CSIR 2017. Solve this question. Here glass slab is moving in the direction of the light. A little bit change is there from the earlier one. Solve this question.
सर 0.58 सी.
ये 0.81 आ रहा है बेटा.
yes, sir. 0.81 C VLO.
Yes, but the velocity of this glass slab. So velocity of the glass slab with respect to observer, that is given how much 0.3 C. 0.3 C. ठीक है. Velocity of the light signal in the glass. Velocity of the light in the glass slab, that is C upon 1.5. This is N. ठीक है.
Yes, sir.
Now you have to find out speed of the signal measured by the observer. So velocity of the light ठीक है ना, as observed by the observer. So you have to find out. So G is missing here, velocity of the light with respect to glass minus velocity of the observer with respect to glass divided by 1 minus VLG VOG divided. Substitute these values beta. ठीक है, you will get 0.81 C. 0.81 C. This will be the answer. ठीक है, तो इसे चेक करना. This will be here. Both are positive. Earlier, when this question was appearing earlier, this was I think one was minus. Out of these two, one was minus. Next question, beta. This question was there in GATE 2017. Question number 17. Question number 17. Is this question there?
Yes.
Question. Yes. And what is the this is the last question, or question number 18 is the last?
JAM 23 question is the last.
Okay. Okay. Beta. Please solve this question then. GATE 2017. Solve this. So I'm saying object is P. Object you consider as P. So velocity of P in the frame of O, that is C by 2. In frame O, velocity of the observer is C by 2. An observer in a frame O prime sees the same object traveling with the C by 4. So velocity of the object in O prime frame, that is C by 4. C by 4. The relative velocity of O prime with respect to O. So velocity of O prime with respect to O. So velocity of O prime with respect to P minus velocity of O with respect to P divided by 1 minus O prime P velocity of OP. Calculate it, beta. Substitute these values and find out. So O prime P will be minus C by 4 minus C by 4 minus OP minus C by 2 minus C by 2 divided by 1 minus C by 4 minus C by 2 divided by C square. This will be velocity O prime with respect to O. बताइए बेटा कितना
2C
है?
by 7.
2C by 7. Very correct बेटा. 2C by 7. This will be your answer. ठीक है, this is the answer बेटा. Last question. Question number 18. Question number 18. This is IIT JAM. Which one? 2013. 23, sorry.
23.
Not 23, sorry. Please solve it. 3 frames F0, F1, F2 are in relative motion. The frame F0 is at rest. F1 is moving with velocity V1. ठीक है ना? F0 is at rest. F1 is moving with velocity Vi with respect to F0. करिए बेटा. तो velocity of frame 1 with respect to F0 कितना दिया है बेटा? ये V1. This is V1 I cap. ठीक है, I cap. F2 is moving with V2 I cap with respect to F1. Velocity of 2 with respect to 1 is V2. That is given as V2. And next, a particle is moving with a velocity V3 with respect to F3. So particle is there, velocity of the particle with respect to F2 is moving with V3 I cap is V3. These velocities are given. If V1, V2, V3 are C by 2, this is C by 2, this is C by 2, this is C by 2. That is given. You have to find out the speed of the particle with respect to F0. So velocity of the particle with respect to O. You want to find out this. बोलिए बेटा, how you are going to find out? So velocity of the P with respect to O. So P is there, O is there, two are missing. One is F1 and F2 they are missing. तो इनमें से कोई भी एक choose कर लो. So I choose one. Suppose velocity of the particle with respect to 1 minus velocity of O with respect to
13
1.
by 14.
13 by
Sir,
14
answer.
beta. That is correct. 0.93
Yes,
C. That is the answer. So divided by,
yes, sir.
correct beta, good. Velocity of P1, velocity of 0, 0, 1 divided by C square. So P1 kitna hai? If you look here, you don't have P1. So I will write here VP1 minus V naught 1. Naught 1 is minus C by 2. So this will be minus plus C by 2 divided by 1. This will be minus plus VP1 C by 2. Is it correct, beta? Hello?
Yes, sir.
Next, अभी मेरे पास P1 नहीं है. I don't have P1. ठीक है, P1 is missing. So I write here VP1. 1 I have already consumed. So P is there, 1 is there, so 2 is missing. So I will write VP2 minus V12 divided by 1 minus VP2 V12 divided by C square. So VP2, P2 is this one, C by 2 minus 1, 2. 1, 2 will be the reverse of this minus C by 2 minus plus C by 2. This will be 1 minus it will be plus. So C by 2 divided by C square. This will cancel out by this. So it will be C here divided by 1 plus 1 by 4. So this will be 4C by 5. ठीक है? So here write 4C upon 5 plus C by 2 divided by 1 plus 4C upon 5 C by 2 divided by C square. So this C square will cancel out. This will be 4 by 5 plus 1 by 2 divided by 1 plus 4 by 5. ठीक है? So this will be 8 here plus 5 here and 10. And this will be 5 plus 9, 5 plus 4, 9 divided by 5.
It is 4 by 10.
This is 4 by 10. Where, beta?
Yes,
Which
sir,
is
4 by 2 was there. 4C
Into
by
2.
5 into C by 2.
okay. This will be 10, beta. Correct.
Yes, sir.
Correct, beta. So I make it correct. Now it will be more simple. So this will be 14 by 10. 10 will cancel out, तो 13/14 बेटा, this will be the answer. तो जो आपने बताया था 0.93, this will be 0.93 C. This will be
Yes,
C
sir.
also. So this will be VPO 0.93 C, and they have written as FC. So what is F? F will be 0.93. ठीक है, this will be your answer. ठीक है ना, this will be the answer beta. So I have discussed most of the questions of this type. Next class will be for the questions of Laurent transformation equation. ठीक है, I will share questions with you, and then I will discuss all these questions, and then I will move further. Okay beta, thank you very much. I will show you all these slides.
Thank
If
you,
you want to
sir.
say
Thank
welcome
you.
beta.
सर
Yes beta.
सर मेरे को क्वेश्चन मतलब पूछना था सर कि सर मैं बुक पढ़ रहा हूँ अर्थर वाइजर का, तो सर थोड़ा सा बुक पढ़ने का राइट वे क्या है सर, मेरे को थोड़ा समझ नहीं आ रहा है, भूल जाता हूँ सर उसको पढ़ते हैं तो फिर वही समझ नहीं आ रहा है।
देखो, you have to read it many times. ठीक है, particularly few chapters. Suppose you are studying STR, तो it will take 1 or 2 readings. ठीक है, 2-3 readings. Some chapters are very interesting, like nuclear physics, statistical, and even they are very simple. You can go through one time, you will understand most of the things. So this is a very very good book. ठीक है, extremely good book. I will suggest everyone to go through this book if you are having time. It will also help in interview. ठीक. So some chapters you need go through these chapters through 2 or 3 times बेटा, तो वो धीरे धीरे समझ आता है. Otherwise, this is a very simple, very in a very mannered way they have written this book. One of the very good book at undergraduate level. ठीक है. So पढ़िए बेटा. Right way ऐसा कुछ नहीं होता कि this is वो everyone is having his own way. But if you are finding it difficult in one go, then please go through this in another way. This is a book like this. I have already studied 5-10 hours in a day. After that, I am very tired. I want some enjoyment, so you can go through this book. In that way, please go through this book. This is a very good book.
सर क्या नाम बताया बुक का?
Uh, this is Modern Physics by Arthur Beiser. This is Modern Physics, Concepts of Modern Physics. Concepts of Modern Physics. Arthur Beiser. This is the book, beta. This is a very good book.
मेरे साथ हो ये रहा सर, एक पैराग्राफ पढ़ लिया तो फिर उसके बाद जब आगे पढ़ते तो उसको भूला भूला लगता है, भूल जाते हैं, तो वही थोड़ा सा प्रॉब्लम हो रहा है।
हाँ, इसीलिए मैं बोल रहा हूँ बेटा कि इसे है ना एक बार पढ़ डालो, रीडिंग ले लो. ठीक है, सोचो मत कितना याद रहा. भाई जब पढ़ रहे हो यू आर अंडरस्टैंडिंग. Then again, after 1 or 2 days, whenever you are getting tired, then read this book. So in this way, if you go through that chapter in which you are finding it difficult 2 or 3 times, then it will be very, very good. You will understand. Sometimes some books takes time, but only in some chapters. Some chapters are so interesting in one go you can remember all those points, all important points from that chapter. Okay, beta.
थैंक यू सर।
थैंक यू.
Welcome, beta.
Thank you, sir.
Welcome,
Thank
beta.
you, sir.
Also, please save all these slides if someone wants. This is first one.
Yes, sir. Yes, sir, please.
Second one, beta. This is second. Third. Fourth. Fifth. Sixth. Sixth. Seven. 8, 9, 10, 11, 12.
Thank you,
Okay,
sir.
beta. Welcome, beta.
Good day, sir.
Good night, beta.